G'day YouTube, Warbles on a lot here. And the Mk-2-B is cooking with gas, as they say. It's almost an hour since I put the sun on the dish. As you can see, the gasometer is holding 2.3 litres and it's bubbling quite furiously. I don't know whether you can see the patterns in the vapours coming out and going into the bottle, but there's a lot of liquid, there's a lot of movement, and it's all going pretty constantly. As you can see. There is a steady reaction going on in the canister. And in less than an hour, not only have I got that 2.3 or 2.5 litres over there, I've already burned 1.2 litres just while checking to see that it would burn. Once again, 100 grams of radiata pine. This is machine joined radiata pine, if that makes a difference. So it's been chopped up and glued back together in a couple of places. The reaction's hot enough that even after it comes through the liquid trap, the vapour's still pretty smoky when it gets into the gasometer. Hear that bubbling noise? That's the sound of energy being turned from photons chemically breaking down the wood and emerging as methane and hydrogen. Holding 3.25 litres, I'm going to have to get rid of some of it, so yeah, that's all burning. Right, now we're only holding 1 litre. I'll just take the temperature. .472, 474, 486, 494. Or 486 as it was when I pressed the hold button. At 1 hour, and in the time it's taken me to measure it and write it down, it's produced another 250 mils of gas. This thing really gets into its stride now with the extended radiation conductive heat transfer bolt, upgraded thermal insulation T-cozy, and last but not least, this past hour I have had clear air, visibility unlimited, completely blue skies between me and the sun. However, there is the first cloud of the day threatening to make an appearance. So yeah, if you can have a couple of days of rain to wash the dust out of the air, and then a still clear sunny morning with no wind to blow the biscuit of hot air away from underneath your gas canister or gasification canister, this is a pretty good system. With y times 0.705 equals x, pretty much as soon as you get to 350 degrees on the bottom of the outside of the bolt, you've got sufficient temperature inside to start forcing off the water vapour. And I'm figuring there's about a 5-minute time lag between getting the maximum temperature on the outside of the bolt and that temperature maximising on the inside of the can. But yeah, once you can get above 250 degrees on the inside of the can, we're currently sitting on 349 degrees, the gasification reaction is fairly constant. All right, that's 5 minutes ago that I did that burn, and it's holding 2250. So 1.15, 1.25 litres in 5 minutes. So I've burned 3.5 litres so far today, and I'm holding 2.5 litres. So that 100 grams of radiata pine has now already produced 6 litres of gas on this good day. In an hour and 7 metres. That's an hour and 7 minutes. There you go, have a bit of a look at the smoke show. Very difficult for me to see what's on screen now, but I can see what's happening in the bottle. And we've still got drops of liquid coming out, puffs of bubbles, and as the pressure fluctuates, as gas is pushed down into the water trap, you get the visual effects in the tar trap glass. Endless hours of fun doing this sort of research, but we're back to 3 litres. So I'm going to have to do another burn to make more room in the gasometer. Back down to 1 litre. Okay, quarter of an hour later, holding 1.26 litres, so it's made 260 mils in a quarter of an hour, with the temperature staying pretty much the same, 349 degrees inside, 496 on the outside of the bottom of the conduction radiation bolt. The glass hasn't got as much milky vapour in there, and it's taking longer between the bubbles. See what I mean? "15 seconds between bubbles." So we add the 1.26 litres it's holding to the 2 litres burnt there, add it to the 2 litres burnt there, add it to the litre burnt there, add it to the 200 mils burnt there, and so far, burnable gas production, I get 6.45 litres of burnable gas, counting the 1.26 litres currently in the gasometer. And although the reaction has slowed down, we're actually about to start getting limited by the clouds that have shown up, rather than the 100 grams of radiata pine having exhausted its capacity to produce gas, because it is still slowly happening. And there is a fair bit of blue sky mixed in among the clouds, so I'll probably just keep going with this batch run and see what I can squeeze out of it. But there might be 40 mils of fluid there, maybe more, as well as 6.5 litres of burnable gas from 100 grams of radiata pine in an hour and a half. And now the jar has almost cleared. And yet the bubbles, they do continue. And maybe the last of the water vapour has been driven out of the wood. Not quite an art form based on guesswork, it's a case of assess, plan, implement and evaluate. A peculiarly streamlined version of the scientific method, marketed to Australia by America in the early 1980s and called the nursing process. Assess, plan, implement and evaluate. So 2600 mils of gas showing at the moment. When the sun comes off it and everything cools down, this will probably shrink and we'll have to call it 2500 1.25 litres rather than 1.26 litres, because that's just another one of the fun things about these low pressure gasometers. They're very, very responsive to Boyle's law. So as temperature changes, pressure changes, volume changes. You have more or less gas depending on how hot it is. But the temperature of the gas doesn't change the calorific value of burning it, so it doesn't really matter. Okay, so there we're showing about 2.9 litres. And it's 20 past 3 in the afternoon, Eastern Daylight Saving Time. I have long since disconnected the gasometer due to cloud as well as tree shading on the dish. The 200 ml jam jar has a lot of liquid in it. That's kind of more than 50 mils from this side. And it looks like about 50 mils from this side. As I told you, the gas sinks in volume as it cools down in temperature. So 40 minutes ago it was actually holding 2 litres, and all of my calculations or allegations are based on that. And what I'm saying is that I've produced 7.45 litres of burnable gas from 100 grams of radiata pine in 2 hours and 18 minutes of having the canister above 250 degrees Celsius on the inside, which compared to the best efforts that the Mark 1 ever achieved, the Mark 1E, 5.95 litres of gas in about 5.5 hours with the canister temperature above pyrolysis baseline. Today I've made 23% more gas in 58.2% less time, so the Mk-2-B is 82.5% more efficient than the Mark 1E, and I'm counting that as a win. So I'll remove the tea cosy, and that's a bit exciting. That's how hot the sticky tape got in the air gap between the inner and the outer tea cosy on the bandage securings, and it's just as bad on the rear side. And wow, look at that, the whole varnish tin has changed colour. We've baked the paint off pretty much half of the can. So, Igor, the convection radiation thermal transfer bolt appears to be working well. Right, let's do this. $40 2.5 mils. And look at that. And 43.8 grams of very carbonised pine. So, 13.7 grams outgassed. And I'll flare this off after dark. Ciao.